Yeah. Good morning. Good morning, everyone. Welcome to the tech talk topic. Welcome to the tech talk. This tech talk is belongs to design and analysis of algorithm DA subject. You can see. Let me introduce myself. Myself S Bhuvaneshwar. You can see my roll number and class in department. I'm from computer science engineering department. Today in this PPT we are going to discuss about the topic a class of sorting algorithms based on quicksort. This is our topic. This is going to be our topic for this tech talk. Let us without any delay, let us go into the video.
Yeah, in this whole PPT, this is the content which you are going to cover in the whole PPT. Like I will first introduce the topic to you, and I will discuss the prerequisites for the topic to let it be understandable to you. And next later I am going to discuss the variations in quicksort, which are the main heart of the topic. And next CK sort and B sort, which are based on the quicksort. And last I am going, like, B sort is one of the base, not the basic. We can't say it as a basic algorithm. B sort is an important variation of the quicksort, and we're going to discuss briefly about the B sort and variations and tracing and the graphs related to the B sort, such that we can understand the time complexities of B sort and how it's different from the quicksort. These are the whole table of content which I am going to discuss in the whole this tech talk or the PPT. Yeah, let me go to the further slides. Yeah, this is the this is the let me introduce the introduction. I'm going to say the introduction. See, although there is no internal storage, no internal sorting algorithm. Like we have two types of algorithms, right? Like internal or external. Internal mean, like, let me introduce let me say what is internal. Internal is internal algorithms which doesn't use any secondary space of the system. Like suppose there are many kind of algorithms. Like as we know, it's we are mainly concerned about the bubble or selection or insertion or merge or quicksort, right? These all are internal algorithms, like which doesn't take any secondary space of the CPU of the system. Like if you have a huge database system, like if you have a sort the whole college list of students, then for sure you should go with the system memory won't sufficient, right? Then you should definitely use the secondary memory. In this case the algorithms are external. Then the sorting algorithms which you use in secondary algorithm space is called an external algorithms. But basically quicksort is an internal algorithms, internal algorithms where let me wait where we are going to use internal space. Yeah, let me go. There is no internal algorithm. Quicksort algorithm introduced by this is the person who introduced quicksorts a list of keys. Suppose there are a list of keys a1 up to n respectively. By choosing a key in the list, a pivot key around which the rearrange the other keys in the list. Ideally the pivot key is near the median value in the list, so that the preceded about half of the followed by other half. The basics is, suppose if you have n digits of array and n array integers, so the quicksort basically follows that. Suppose if you choose the first element, you can choose any element, first or last or middle. Like it's based on completely on the pivot element which choose. You can choose a pivot element as any. Basically in quicksort what happens is, if you after completion of one iteration, after completion of one procedure, it's ideally if you should take iteration, it's like it's more applied. The iteration word is more applied, I think. So let me consider iteration. After completion of one iteration, the first element or the pivot element which you consider will be placed in the exact position where it should be after the sorting. After that, the first of which before the pivot element, it will be numbers which is less than the pivot element, and the second of will be greater elements which are than the pivot element. And next again the quick sort algorithm will be applied to this of and this of again the subsequence, and this is which goes on the divide and conquer method. Like now after completion of whole sorting, the whole array which you get is been sorted out. This is a basic principle which the quicksort follows. Yeah, now I discussed it briefly. Even you can see on my screen. Let me erase my screen. Yeah, you can share my screen. The keys of list are now arranged such that a of 1, a of 2 contains all keys with values less than m, and after j, all j plus 1, like after j, consider j1, j2, j3 contains all other keys with greater than or equal to. Like first half is first half after first half before the pivot element or lesser element, the next half which are about the greater elements. This is the basic procedure which the quicksort follows. The elements A1, A2, AJ are called the sublist, of are the right sublist. Like you can take this and left sublist, this can right sublist. This is the basic idea of the quicksort. Yeah. Now there have been many improvements and quicksort. There are many improvements and modification for the quicksort. Like you can consider the first element as an pivot element, last or middle. Whereas the quicksort partition the original list using the first element as an estimate of the median. Quicksort sorts partitions using the middle list elements as an estimate of the median. Some other descents and quicker sort may be found by using more decent variations. Mean sort have been proposed. Like instead of considering first or last, we can consider a median element. This is one more proposal which we have, not proposal kind of which we have in using implemented. Mean sort not only select any particularity control the partition. Instead, the partition is determined by mean value of the each list. Like we are going to consider the mean value of the each list, and then we are going to apply the quicksort algorithm again. However, the fundamental drawback of the quicksort is variations remain the same. The worst case behavior of one occurs when they nearly sorted or nearly sorted in reverse order. Like if the given array is in nearly sorted or in reverse, again the worst complex will be by mistake I hit it will be O of n square. No, sorry, it will be O of n. Although it would seem that complex sorted nearly sorted the list would be least time. Even we can when we have possibility of sorting it in n log of n, why O log again. Now here the one of which we discuss now we discuss the quicksort. There are many sorts which came on the class. The topic is the class of quicksort algorithm. What does mean a class then? A class means sub algorithms which are mostly related or conceptually based on the given particular algorithm. Like CK sort, this Y sort, and next we are going to discuss next D sort, B sort, and these are mostly based on the technique of quicksort. There was some changes were made to quicksort, so then we arrayed this particular sorts. Now we will discuss this CK sort and where these are way more better than the quicksort and where they are drawbacking getting behind the quicksort. Now see, let us discuss about the CK sort. CK sort is an excellent sorting algorithm for nearly sorted list, which for lack of any other nomenclature we refer rather than CK sort. CK sort is a combination of straight insertion sort and quicker sort. Like CK sort is just basically insertion sort. Like suppose we consider an element, we start here. Suppose we take this element and we first element is we keep it as it is. Next we consider this element. If the we insert this element in such a way that it should be in ascending order. Next we will consider this element, and if this we arrange this element in between this, if this element is less than this and this, we will arrange the first. Suppose consider the array 2 1 3. In insertion sort, first element will be here. Now here 1 is before 2, right? Just move this 2 here and put 1 here, and now 3 compare here 1 2 3. Now 3 is in already in ascending order, right? 3 is now already in ascending order. Keep 3 here, 1 2 3. Yeah, now we got a sorter. This is the basic procedure of an insertion sort. Now we can combine by combining both insertion sort technique and quicker sort technique with merging, we finally occurred in another sort called quicksort. Quicksort is combination of quicker insertion and quicker sort with design specially for nearly sorted list. If the array was nearly sorted, to reduce the time complexity, we are merging the both insertion sort and quicksort. So we find there as CK sort. It promptly of another distance of key, including nearly sorted in reverse. Even if the elements are nearly sorted in reverse, we can use this CK sort so that we can reduce the complexity. Yeah, let me clear my screen. Yeah, you can see CK sort is an excellent sort algorithm for nearly sorted, which is lack of any other nomenclature. CK sort is combining of insertion and quicker sort. Yeah, this is the slide. This is the graph which you can see. Let me, after going to discuss I will discuss the graphs after some time. Yeah. CK sort original list is scanned and pairs of unordered are removed and placed like this is the given array 1 2 3 4. Now basically CK what the CK sort does is original list this takes into the pairs this pair and now it will pair unordered elements and remove the placed in another way. After pair of unordered elements have been removed, next pair compared in the elements immediately preceding and immediately after the pair just removed. After repeating this all the elements in the original list, the array unordered elements in the sorted by straight insertion and there is no more 30 elements in the quicker sort otherwise. Finally, two arrays are merged into the array. Yeah, this is the quicksort basically follows. Yeah, let you see the graph of like this is the first line indicates CK sort, second is quick sort. You can see for CK sort when order data elements are very less and the elements are really low, the time complexity of CK sort is much lesser than the quick sort. CK sort is less than the quick sort. As the elements increase are and not in the exactly nearly same, the quick sort is much better. But this is the one of the variation of quick sort. Yeah, this is the which I discussed earlier. Yeah, let us consider one more variation of quick sort, which is B sort. Like it's one more way more not we can call it better than quick sort, but one of the variation in some areas of which is better than quick sort. Yeah. B sort. The technique on the variation of quicksort is a variation of quicksort that is designed to work best for nearly sorted list as well as nearly sorted in reverse. Even this is made for nearly sorted list and nearly B sort requires no more than n log. Like B sort just require n log of comparison. In fact, for sorted or list sorted in reverse, the algorithms take zero of comparison. B sort uses the technique associated with the bubble sort. Like as we see in the quick sort, we choose insertion and insertion and quick sort. Here the B sort uses bubble sort and insertion. Bubble sort and quick sort. Here the combination of bubble sort and by combining bubble sort and what we call so quick sort, we added the B sort. In a bubble sort, a check is made after each pass. Like as we know that bubble sort, we will check every element and we pass the maximal later. Suppose this is an array. After one iteration, the max element was placed here. Again, we are going to iterate. The max element is placed. Again, we are going to iterate the max. This is going to be the procedure where we are going to place the max element there. This is the basic procedure of the bubble sort. After completion of all the iteration procedure, we are going to get the final sorted array in the bubble sort. It is easy to determine if the list is sorted or not after each pass been completed. Similarly, yeah. Now let us see the algorithm for B sort. How B sort works. As in quick sort, B sort selects. Yeah. As in B sort selects. Yeah, as in quicker sort, B sort selects the middle key during each pass as the key controlling the partitioning process. The algorithm then proceeds as in traditional quick sorts. Each key that is selected into the left subfile is done as into the right end of the subfile. If the new key is not in the first key of the subfile, subfile means you can even consider an array, comparison is made between the new key and left neighbor. Ensure that pair of keys in sorted order. If not, they are in the interchange. Similarly, each and new key that is placed in the right subfile is done at the left end of the subfile. If new key is not the first key of the subfile, a comparison is made between the new key and right neighbor of the ensure the pair of key in sorted order. If not, they are interchanged. Yeah, thus at a point in consist of subfile, a rightmost key is largest in value at the leftmost. Now, when the partition process is when the partition process is finished and there were no interchanges are performed during the construction of a subfile, then its keys are in sorted order and further partitioning is undid. This is the major advantages of B sort B sort over the quick sort. In addition, if a subfile has only two keys, then by the above mentioned construction it is sorted. If the subfile has three keys, it can be sorted by making one comparison and possibly one interchange. A subfile will not be partition further unless it has at least four keys, when represent a second advantage over the quicksort. The partition process smaller subfiles first may upgrade in order to minimize the stack. The algorithms is finished when all the subfiles are sorted. The file examples illustrate how the bubble sort B sort algorithm works. Now let us see the tracing of the B sort. Let us see with an animation how B sort works. Let me display an animation how this B sort works. You can see on my screen. Let us take an array of elements which we consider as which you can see on my screen: 91, 62, 3, 84, 50, 10, 97, and 28. Now initially pointer starts here. Sorry, let me change my slides. Yes, sorry for the interruption. Let us see now the tracing. Consider the following file with middle key 35. The middle key is given as 35 as the pivot as the pivot key controlling the partitioning process. We start with two pointers I and j pointing to the left and rightmost keys in the file respectively. Consider this keys 91, 62, 384. That it. 34, 10, 95, 95 as middle bit is 35. Now consider the pointers from starting and beginning as I and j. Consider the I and j as starting and last pointers. Next, first we attempt to move I to right until now we will try to attempt one move I to right until a number larger than or equal to the pivot value is found. In this case, since I rest on 91, it does not change the remains on 91. Next we move j to the left until a number less than the pivot value is found. This yields the following. You can see on the screen the animation. I didn't change its position, whereas j changed its position. As 91 is larger than 35, it doesn't change the position, whereas 49 is larger than the 35. It changed its position. Now next move I to the right again until it rests on the value larger than or equal to pivot. Then the value in this case is 62. Move left until it rests on the value less than the pivot. In this case 10. Note that j passes over 97 and values 49, 97s are exchanged and preserving the leftmost value in the right subtitle of the further. This yields, you can see on this by interchanging and those all, this is 28, 42, 3, 84, 35, 10 and 49, 97 and 9. This yield is, we exchange key pointed to the by I and j yielding 28, 3, 84, 35, 62, 49, 97 and 91. Now we preserve the rightmost key to be the left subfile as the larger and leftmost key right subfile as the smallest exchange. 28 with 10 and 62 with 49. Since an exchange has now occurred in the left subfile, it will not necessarily to be sorted other than when partitioning the subfields. 10, 28, 3, 84, 35, 49, 62, 17, 79, 91. Now I moves at the 3 and J moves at 62. Finally, now move I right to the 84, exchange 28 with 3 along with way and move I J lefts and also 84 yielding. Now I J will, we can see I J will point to the same 84 now. You can see on my screen like I J points to the 84 now. And the process terminates when ij and meets. The key pointed to by ij must now place it into the proper subfile. Since 84 is larger than the pivot, it belongs in the right subfile and 34, 84 are exchanged yielding the final partition. 10, 3, 28 as separated subfile and 34, 84, 49, 62, 79 which you can see on my screen are divided into two subcategory subfiles. Now we should perform again the sort on these two arrays, so we can finally get a sorted array here. Here any subfile of length 3 can be placed in order by volume 23 communication with ACM 95 accounting the brackets of comparison. Change after exchanging 10 with 3, the subfile is sorted, then the original problem has now reduced into the sorting file. Yeah, now we can go to 84, 49, 69, 91. This is going to be how the tracing of the B sort works. And this graph shows the various time complexities of quicksort, CK sort, merge sort and BM sort and X. These are different variations of quicksort. You can compare these variations with the different data number of instructions in the number of input data values, and you can see the time to complexity, and you can compare which suits well for your suitable application of the program or your project, and you can choose your algorithm wisely here. And this is this is the reference link which I used to make this PPT. You can go through the link and you can find more variations of quicksort, and you can learn more sorts according to this link, and you can find the various complexities and graphs so that you can choose algorithms suitable sort for your project. Thank you. I think so we discussed everything related to this, from starting tracing B sort algorithms. This is the whole tracing here. We discussed the tracing. Yeah, I showed an animation of B sort. Yeah, and we saw the C here. We can see the procedure of quicksort, definition, introduction. I think so we have covered this all here. Yeah, you can see on smoothly, like a quick recap. You can see. Yeah, you can see on my screen what is going here. These are reference link you can follow. Yeah, thank you.